Alrighty, guys. So let's go over our action potential phases once again. That way we could try our best to kind of get it down a little bit to the nitty gritty. So first things first, let me write a my let me try my best to draw a ECG here for you guys. So you have your P wave followed by your QRS. Ooh, a little wonky there. And then your little T wave at the end. I want to do a little best T wave right here. Not the best, guys. Sorry about that. But let me try to trace it as best as I can. That way it can look a little bit more decent for you. Anyways, well, let's start with phase 0 while I'm tracing this. What do we know about phase 0? So, phase 0, let's see here. I'll write it right here. Phase 0 is actually in the what? What do we know about phase 0? It needs to be actually in the, it's not, it doesn't need to be. It's in the negative, about the -90 and -70. Kind of messed up a little bit there. It needs to be around the -70 and the -90 millivolts. Okay, so if you look in your book, page 1170, like I've mentioned before, this little phase is going to be that, it's going to slowly be that contraction phase if you actually get there. So remember what I mentioned about that influx street? Calcium is the one that needs to be in there so it can cause that contraction. So calcium is there, it needs to actually cause a depolarization, but however, in phase 0, this is negative, right? It's negatively charged. So how is it going to become a positive? Well, that's where it actually goes into a that's where we go into phase 1. And it's all in the name, guys. So in phase 1, sodium, Na, goes into what? Goes into another cell, another cardiac cell, goes into cell, and what comes out? Your potassium comes out the cell. Comes out the cell. There you go. This is for phase 1. So let's see. For phase 0, it actually, right here, it's the negative charge is right there. And notice that it's a downwards deflection. And that's where we have that negativity here. And now phase 1, it's actually going to be located right at the QRS when depolarization is actually happening. So let me write a nasty line there. Totally horrible. Let me give that one another go. Oh, even better. There you go. Okay, so now we move into phase 2. Phase 2, and I wrote it in a yellow form. Why? Because what does yellow mean on a stop sign? Slow down. Slow down. So this is where this means, right? So in phase 2, what's also coming in? So where do you know that, sodium wins in? So sodium goes in, and which one is the sneaky one? Calcium is a little slow, a little nonchalant, and that one is the plateau phase. Plateau phase. There you go. And it's calcium. Remember, it has what? Oh, okay, that was weird. It has 2 jobs, which is to what? Stabilize and contract. Now that we basically were in that influx street again, don't forget that influx, the calcium goes into that influx, into that sarcoplasmic reticulum. And this is basically what it's going to do. It's going to stabilize and it's going to make it contract. So good. Calcium is there doing its job, but at the same time now we also have potassium. So this is where potassium is going to be slowly moving out the cell as well. It's going to be slowly. By what I mean slowly, it's like literally slowly. Why? Because this is where we're going to be, right there, slowly. Really moves out. And this is where we have, now I'm going to go over here to phase 3. I hope we still have a little bit of time to write right here. Now we're going to go to phase 3. And remember what I mentioned about phase 3? Phase 3 is usually the final phase of repolarization, which is going to be somewhere around this area right there. On the T wave, sorry, on the 3 wave. On the T wave. So this is the repolarization, the final stage of repolarization. So this is where you have your calcium that, remember, because it's slowly, it has those sodium channels that close slowly now. I mean, those calcium channels, sorry about that. And it also has the potassium channels that close out slowly. So now that they're actually leaving the cell, I have no clue why that. Let's see. Now that these two cells, what the hell? Now that these two cells left, well, sodium is left all alone. Think of it that way. But sodium already did its part. Sodium actually became positive because of that. But now, calcium and potassium left. So we're back to what? Phase 3 is done. And now we're moving on to phase 4. And what is phase 4? Let's see. Phase 4, basically all over again. It's at the end stage where it has that threshold potential on that resting membrane. If you guys see that other little graph that it has, not the ECG, but the little graph that it has, and it's there. And basically we're going to be going back to phase 1. So in phase 4 is basically getting ready to get that exchange again. It's looking for that exchange, and it's going to be looking for the same thing. Now we're going to be looking for that sodium and potassium to get changed out again. All right, sodium comes in, potassium also comes out, and it's going to be going all over again, guys. All over again. I know it might be a little confusing, but trust me, if you actually go over it a few times, quite a few times, and it's like I said in page 1170, ending in 1171, it's not too long, doesn't take more than a couple minutes to read. Look it over, guys, and read it. Read it. So remember, so let's go at it just one more time, real quick. We have phase 0, which is sodium is in the negative charge, and it's going to go into the cell. It's going to go into the cell, and it's going to become positive now. So sodium goes into the cell, potassium comes out the cell. Okay? And then while that is going on, we're in that plateau phase. Calcium comes in, and it stabilizes that membrane, and it also uses it to contract. Okay? And potassium is actually slowly moving its way out those channels. Now, it takes super long to close those channels, but in phase 3, that's when calcium and potassium finally leave. Remember, like I have mentioned, like in that superstore, when you have those two people that are like talking to each other for eternity and they never leave that line? Well, that's exactly what's happening with calcium and potassium. But in phase 3, they finally leave, and now your cell is back to a negative charge. And that's where we go back to phase 4, because it wants that exchange. It wants that exchange now. And now sodium is actually looking for that exchange again as well. Why? Because sodium wants to become positively charged again, because it's that sodium-potassium pump that makes the cardiac cells go round. Well, actually, I'm sorry, correction. It's it wants to go around and make sure that contractility is there. And it goes hand in hand with calcium. Calcium's job is actually to make the heart what? Contract and to stabilize. But everybody works together in this part. Okay? So I hope this helps you guys out a little bit. Let me know if you guys want something like this, a little bit more. Any feedback is greatly recommended, because I'm trying my best here to help you guys out on this. And all right, guys, you guys have a good day.